Alright, so this problem's going to be a little tricky if you don't really follow it. So in the instructions that we don't see right now, it's saying all lines that appear to be tangent are tangent. So that means we have JK and KL are tangent. Based off the instructions. Alright, so the goal of this problem is to find this arc. Well, we got a problem right here. We were only given the outside angle. We're only given the outside angle. So to find what this arc is, which we can, we're going to have to do something a little intuitive. If these two lines are tangent, that means I'm going to draw a line from here to here. So remember, we have JK and KL, they're both tangent. And then now we have, I don't remember if there's a center to it, but if it goes from the radius, we have a radius right now, 90 degrees is developed. So we have a central angle. With the central angle, we know that the central angle, this angle, is going to be the same as, where's a good color? This angle is going to be the same as this angle. We know that we have this kite. It looks like a kite. And so we have 3 of the 4 angles. So to find it, we know that a 4-sided figure has 360 degrees of degrees, or 360 degrees for the interior angles. Then we have 90, 90, and 75. So I'm going to add 90 plus 90 plus, we'll call this C for central angle, plus C plus 75. So we're going to add these all up. Get 360 plus, oops, not 360, 90 plus 90 plus 75. In descending order, should have done it before, 360 is equal to C plus 255. Then the inverse of addition is subtraction. We get right here 105 equals C. So we get 105 degrees for C. So we got 105 degrees right here. Well, we'll do it the long way, but then I'll show you what you could also do here. So we have an outside angle, we have the small arc, now we need to find JL. If you can recall, the formula says the following. The outside angle, which is the orange, is equal to 1/2 the large arc, so we can call what's a good word? The outside arc. The large arc minus the smaller arc. That's a nice, quick way to say it. I don't know if it's the best, but it makes sense. JL. And then the small arc. So from here, outside angle is going to be 75, which is equal to 1/2 the large arc. We don't know it. JL. I'm assuming it's going to be a major arc, but I'm just going to say JL because that's all they gave us. Minus 105. So the first thing I see is I don't want to distribute a half here. So what I'm going to do is do the inverse of division, which is multiplication. So I want to multiply both sides by 2. Question mark. I'll just change that to. The 2 cancels with the half because 2 divided by 2 is 1. And then 2 times 75 should be 150. So you get 150 is equal to question mark minus 105. Then here, the inverse of, move it up a little bit. The inverse of subtraction is addition, so we're going to add both sides by 105. You get 255 equals question mark. So you could do it this way for this problem. Move it up a little bit more. Or you had 2 tangent lines. That means if that's 105, you could have just done 360 minus 105, I believe. Yeah. You could have just done 360 minus 105 because these are the 2 distinct stopping points. So you could have done that as well, so you don't have to do that formula if you don't want to. This work right here, as long as you can tell me this part, is sufficient. So 255. And the way we did that is the circles that go to 360. We found one of the arcs. There's only 2 parts, so 360 minus 105 will get you the question mark. All right, there you go.